Let's find the interval and the radius of convergence for the given series. Since this is not something raised to a power k, we must apply the ratio test. And remember, for the ratio test, we want absolute value of ak plus 1 over ak. ak plus 1 means plug k plus 1 in for k. That's x to the 2 k plus 1 plus 1. That k became k plus 1, watch your parentheses, over 13k plus 1 minus 1. ak is this stuff, so dividing by that means multiplying by the reciprocal. We have absolute values, and we're looking to see what simplifies. Well, this is 13 to the k plus 1 minus 1 is k, and that's 13 to the k minus 1. So I have one extra k in the denominator, or 13 in the denominator. This is 2k plus 2 plus 1, which is 2k plus 3. And this is 2k plus 1. So there's two extra x's in the numerator. So that's x squared. This is what our absolute value ak plus 1 over ak simplifies to. So we're really looking at the limit as k goes to infinity of absolute value of x squared over 13. Since there's no k's at all, that is just absolute value of x squared over 13. But since x squared is positive, that's just x squared over 13. When we apply the ratio test, we want that value, that limit, to be less than 1. So we're looking at x squared over 13 less than 1. That leaves me x squared is less than 13. Take square root of both sides, which is square root of x squared is really the absolute value of x, so it does pop back in for us, giving us the square root of 13, which makes negative root 13 less than x less than positive root 13, so that the radius of convergence is the square root of 13. Okay, now we do need to check our endpoints. If x is equal to square root of 13, let's look at the right one first. Then this becomes square root of 13 to the 2k plus 1 over 13 to the k minus 1. Well, that's 13 to the 1/2 to the 2k plus 1. Over 13 to the k minus 1. Which means that we're subtracting 13 to something over 13 to something else. Is sum of 13 to distribute this through makes k plus 1/2 minus k minus 1. Subtracting the denominator's exponent. K's cancel away. That minus minus makes plus. So this is sum of 13 raised to the 3/2, which is 13 to the 3/2 plus 13 to the 3/2 all the way over and over and over, which definitely does not converge, which definitely diverges, because we're adding up the same number forever. If we were to put a negative square root of 13 in, all that would change is that I would have a negative 13 here, which would change this to alternating out front, but doesn't change the underlying fact that this is a constant number added up forever, so it also diverges. So that the interval of convergence is negative root 13 to positive root 13, including neither endpoint.